Today we are going to determine whether a point is on a line. And so the way we're going to do that is we're going to use substitution and then evaluate an expression to see if it equals the number, the expression that the variables are set equal to. So for instance, here we have an equation, negative 4x plus 2y equals 8. And we have this point 1, 6. We want to see if this point is on this line. So what we need to do is figure out what is the x value, what is the y value. Well, here's our x value right here, and this is our y value. And so all we're going to do is we're going to take this 1 and we're going to put that in place of x. We're going to substitute. We're going to take the 6 and we're going to put that in place of y. And so what we've got is a numerical expression, and we just need to evaluate it. So negative 4 times by, but in place of that x, we are putting the number 1. And then we have, to write the rest of it, we've got the plus sign, and we've got the 2, but we are multiplying instead of y, we're going to write the number 6, because that's what y equals. That's what the point says. And then once we do that, we're going to go ahead and do some work on that left-hand side of that equal sign and see if it does equal 8. And so we go ahead and do this work here. Negative 4 times by 1 makes negative 4. 2 times by 6 makes positive 12. And those two numbers do equal 8. And when the two numbers do equal each other, we say yes. Yes, that point is on the line. So there would be our answer. So the proof is in the expression here that we had evaluated, and if the two numbers agree again, yes, the point is on the line. Well, let's take a look at the next one here. We've got a different equation, and what's different is we've got a fraction and maybe some more negative signs as well. We do the same sort of thing. Remember, this is our x value, this is our y value. Ordered pairs always go in alphabetical order. X comes before y in the alphabet, so that's why the x term is first and the y is second. So here we take this 16 and we're going to put that in place of the x. We're going to take this 5, put it in place of the y. And then we'll rewrite our expression in just numerals, just numbers. And so we've got a 1/4 times by 16. So instead of writing 16, I'm going to write 16 over 1 so you can see the cross-canceling that will occur. And then minus 2, and then we're going to write down the term that we're going to substitute in there, which is 5. And this should all equal negative 16. So we go ahead and do some work there. Got some cross-canceling to do, so we're going to cancel out this 4, and it goes into 16 4 times. So we'll see what's left over here. So we go ahead and rewrite our expression when we multiply. 1 times 4 makes 4. And then careful in the signs here, negative 2 times positive 5 makes a negative 10. And this should equal negative 6, not 16. So I wrote something down there wrong. Let's go ahead and fix that right now. So it should just be negative 6. I think I was looking over at this 16 here. Anyhow, we'll go ahead and bring that equal sign down, and this equals negative 6 again. Again, you're just bringing down that number. And then from there, we go ahead and do some more work. We subtract that 10 from 4, and we get ourselves negative 6. So negative 6 does equal negative 6. Again, since those two numbers agree, we say yes, that point is on the line. So the proof is in the evaluation here, seeing if the two numbers agree. If they agree, then yes, that point is truly on that line. Or we could say that point is a solution of that equation. Well, letter C here, we need a point to go along with this. So let's use the point negative 2, negative 12. So there's our point. And now we're going to see if that point is on this line, or this equation, or this graph, we could say. So we're going to take the x value, again, x is always first, take that negative 2, and we're going to put it in place of x. Then we're going to take this y term here and put that in place of y. And we're going to see if it equals. So what we do is just substitute. And we'll bring down this negative 6 times by, but in place of that x, we're going to end up putting that negative 2. And then we bring down that minus 4, or actually minus 1/4, and then we multiply by negative 12. But remember, since we've got a fraction, I'm going to write this negative 12 as a fraction, negative 12 over 1. And then we're going to see, once we multiply and evaluate a little further, we're going to see, does this truly equal 9? So we go ahead and do some work there. Negative 6 times negative 2 does make positive 12. And here, careful on this. This is where I see a lot of errors when people do this problem. See, we have to multiply negative 1/4 times negative 12. So these the 4 is going to go into the 12 3 times, but we still have the 2 negatives. So what's a negative times a negative make? Well, hopefully you said it right. It makes a positive. So it's not minus 3, it's plus 3. And that should all equal 9. But it doesn't. 12 plus 3 makes 15, and those two numbers are not the same. 15 does not equal 9. So that means this point is not on this line. So then we say, no, it's not on the line. The proof's right here. 15 doesn't equal 9. So again, make sure that you're watching those signs. Negative times a negative makes a positive. Now I got one more example here for this set of directions, and it's where we have another fraction as a coefficient. And 1/3 x minus 2y should equal 7. But we're going to see if this point, x, which is 9 here, we substitute it in there, and we take the y value, negative 2, and put that in there. Let's see if those two numbers go in for x and evaluate here to equal 7. If they do, then that means that point is on the line. So we go ahead and do the work. We've got a 1/3 multiplied by our x term. X term in this case is 9. So I'm not going to write just 9. I'm going to write 9 over 1 so you can see that cross canceling that will occur. And then I'm going to bring down that minus sign, bring down the 2, and then multiply not by positive 2, but negative 2. So you really got to be careful of these signs here. Hopefully you see negative times a negative. You're thinking positive already. And so we bring down the equal sign, bring down the 7. So here's where we do some work. We've got to deal with this part first. And so we've got this 3 will go into 9. 3 goes into 9 3 times. And so we go ahead and multiply those two numbers. And that leaves us with 3. Now again, remember what I said. We've got this negative here, and we're going to multiply by this negative. So watch that sign very closely. It doesn't make a negative, it makes a positive, and that makes positive 4. And sure enough, those two numbers do add to make 7. So that means that our answer would be yes, that point is on that line. And there it is. So this is a technique that's used in this class, and then also I've seen it in geometry classes too. They ask us to prove a point is on a line. Well, this is our proof. Our proof is to substitute the numbers that were given for the point into the equation. And if they equal, you say yes, that point's on a line. If it's no, because they don't equal, then you say no, it's not on that line.